Okay, this is a review of lessons 9.3 and 9.4. We are starting with the 9.3 worksheet. So number one, if f of x equals x squared plus 3, we're going to complete all of this based on that. So first we're going to fill in the table. You can always plug this into your y equals if you have a graphing calculator and hit table, fill it out. You can also just run everything through. This is a simple enough equation, it's not too difficult. So we plug in negative 3 squared is positive 9, plus 3 is 12. Remember, a negative times a negative. If you are going to put negative 3 squared in the calculator, if you do it and you get a negative 12, you should know that's wrong because it's negative 3 times negative 3. That means you didn't put parentheses around the negative 3 when you squared it. It will only square the 3. It will leave the negative out front, so be careful. We know that anything squared means a number times itself, and a negative times a negative is a positive, so we have to make sure we remember that. Negative 2 squared is 4, plus 3 is 7. Negative 1 squared is 1, plus 3 is 4. 0 squared is 0, plus 3 is 3. 1 squared is 1, 1 times 1, plus 3 is 4, and so we start to see the symmetrical side here. 2 squared is 4, plus 3 is 7. 3 squared plus 3 is 9, plus 12. So right here is our vertex. Symmetrical on both sides. We're going to have the same y values as we go away from that. An equal number of units. So when we graph this, I'm going to start with my vertex. Now I'm going to have to think about what do I want to label these. These I can go by 1. That's no problem. But these I really want to get up to 12. And if I count by 1s, I'm not going to get there. So what if I count by 3s or 4s, something like that. So if I counted by 3s, this would be 3, 6, 9, 12. We don't need 15, but it's right there. So 0, 3 goes right here. 1, 4 between 3 and 6. So right here. Negative 1, 4 also right here. 2, 7 just above the 6. Negative 2, 7 just above the 6. 3, 12 and negative 3, 12. So there's our graph. Scoop it up. Letter C. Does the function have x-intercepts? No, never going to hit that x-axis. Y-intercepts? Yes. And the y-intercept is 0, 3. If so, what are their values? We gave it to you right there. So no for x, yes for y. 0, 3 is the y-intercept. Describe the range. Remember, those are your y values. So there are no negative y values on this function. 0 is not there. 1, 2 is not a function. It starts at 3. 3 is part of this function, and everything above it is as well. So every number that's greater than 3, but also including 3. So y is greater than or equal to 3. That's the range. All right, number 2. Similar. So first of all, when we plug in, remember that this gets squared first. Then you multiply. Order of operations says the last thing I'm going to do here is add. So negative 2 squared is 4. 4 times negative 2 is negative 8. Plus 1 is negative 7. Okay, if I was going to try and put that all in the calculator, it's going to have to look like this. Negative 2 times, then in parentheses, negative 2 raised to the second plus 1. And there's my negative 7. So you can put it all in the calculator, but you do need to be careful with those parentheses. So negative 1 squared is 1 times anything is itself. So negative 2 plus 1, that's negative 1. 0 is going to cancel all of this out, so plus 1 is 1. Plugging in 1 should be similar to negative 1 because we're squaring it. So 1 squared, 1 times 1 is 1, times negative 2 is still negative 2, plus 1 is negative 1. So you start to see this is our vertex. It's going to be symmetrical on both sides. So this should be negative 7. 2 squared is 4, times negative 2 is negative 8, plus 1 is negative 7. All right, real quick, let's graph this. We got to get up to 7. So 1, 2, 3, 4, 5, well, negative 7. But either way, counting by 1s isn't going to do it. So we're going to go by 2s. Negative 2, negative 4, negative 6, negative 8. Side to side, we can count by ones. So 0, 1, so remember this is 2 then if we're counting by 2's. So 0, 1 is going to be here, between the 0 and the 2. Negative 1, I'm going to go negative 1, negative 2, negative 3. Each line just worth 1 going this way. Remember that the units that you count by don't have to be the same, but whatever you do in the negatives of the x, you would have to count by the same thing in the positives. That can't change. But your x and your y in terms of what you're counting by per box does not have to be the same. So negative 1, negative 1. Don't go down 1 because that's actually negative 2. So it's going to be here. Positive 1, negative 1. Symmetrical on the other side. Negative 2, negative 7. Past the 6. Not all the way to the 8. Same thing for positive 2, negative 7. Okay, so this equation is in this form. There's an A, there's a B, there's a C. But when I bring this down, I don't have 3 terms, I only have 2. I'm missing 1. I don't have this middle one with the x on it. I have an x squared and I have a number by itself. So I have an A and I have a C. B, I have 1, but it's 0 because I multiplied and got rid of x. So this must be 0. So my A is in front of the x squared. So A equals negative 2. B equals 0 because it's not there. And C equals 1. Which one of these values represent the y-intercept? So go up to your graph. Where does it hit the y-axis? Right here at 0, 1. So C represents my y-intercept. What's the equation of axis of symmetry? So that is the line that cuts this into 2 symmetrical sides. That's why it's called the axis of symmetry. So it cuts this in half. So this axis of symmetry, any line that runs straight up and down is x equals something. That is the form of the equation because no matter where we go on this line, the x value is the same. So this one happens to run right on that y-axis. So what is the value of x on the y-axis? It's not positive, it's not negative, it's 0. So no matter where I go on the y-axis, the x is 0. So the equation of this line is x equals 0. And now what are the y-intercepts? I'm sorry, x-intercepts. We know the y-intercept is 0, 1. The x-intercept is in here, and it's hitting somewhere in between 0 and negative 1 and 0 and positive 1. So it's a decimal. We're going to have to do the math. Remember, this was my y-intercept, and the x is 0 for my y-intercept. So the opposite is true. At this point right here and this point right here, where it hits the x-axis, the y value is 0. It's not up, it's not down, it's 0. So what I got to do is I have to go over here and plug in 0 for y and solve for x. So I have my equation. If I wanted to find the y-intercept, I'd plug in 0 here, which I already did, right? Plugged in 0 and ended up with 0 plus 1 is 1. So my y-intercept is 1. If I want the x-intercept, I have to plug in 0 for y and solve for x. So I got to isolate x. So first thing I'm going to do is minus 1. So I'm left with negative 2x squared equals negative 1. Divide by negative 2. Cancels this out. So I'm left with x squared. On the right side of the equation, 2 negatives make a positive 1/2. That's the same as 0.5, right? So what I'm going to have to do is I'm going to have to square root this in order to get x by itself. So square rooting x squared gives me x. Remember, when you square root, you get the positive and the negative version. And so I need to square root 0.5, or you could put the fraction in. And I get this. We're going to round it. We're just going to call that 0.7. So the x-intercepts is going to be positive and negative 0.7. If you're going to give the coordinates, remember these are the x values. So it would be negative 0.7, and what's the y? 0. And positive 0.7, 0. And that's right here. So that should make sense if we think about it. Between 0 and 1, it actually looks a little closer to 1. That's the 0.7. Between 0 and negative 1, that's the negative 0.7. Okay, so when you square root, don't forget there's a positive and a negative. Okay, we are moving to the 9.4 worksheet. So on these now we're looking at projectiles, so they're going to follow the form of a parabola, but we're looking specifically at these projectiles. Suppose the height of a ball versus time is given by this formula. Is the height of the ball measured in feet or meters? To figure that out, you look right here. We've got our different numbers. Negative 16 is for feet. Negative 4.9 is for meters. So we know that this is in feet. At what height was the ball released? So the initial height is always found right here, so 6 feet. And what was the initial velocity? That comes from this point right here, 23 feet per second. So question number 1 is basically just going over, do you understand the equation? Do you know where to find information? Plug it in. Now we're going to go ahead and do that in question number 2. So suppose a ball is thrown upward, starting at a height of 5 feet. So remember, that's your initial height. So we're going to have a plus 5. And the initial velocity, which goes right here in the middle, is 35. So go ahead and write the equation. Now we're doing this in feet. So when I write this, height equals negative 16t squared. It would be negative 4.9 if this was meters, plus our velocity times time, so 35 times t, plus our initial height of 5. So go ahead and find the height of the ball after 2 seconds. That just means take your equation and plug in 2 for t. So h equals negative 16 times 2 squared plus 35 times 2 plus 5. You can get this all in the calculator. Make sure that you put parentheses if you have a negative. So I actually don't need it here because it's positive 2. But it doesn't mean it's not a good thing to still do. And I get 11. Okay, and you can do that one at a time. 2 squared is 4 times this. 2 times 35 is 70, and then add it all up. And you're going to get 11, but you can plug it all in the calculator too. So this is letter B. And letter C. Is the ball still in the air after 3 seconds? So what we want to do is we're going to go ahead and plug in 3 and see what the height is. If it's negative, then we know it already hit the ground. If it's 0, we know it's hitting the ground at 3 seconds. If it's still a positive number, then that means the ball is still in the air. So h equals negative 16 times 3 squared plus 35 times 3 plus 5. So this one, let's run it all the way up. So negative 16, 3 squared is 9, so times 9, plus 35 times 3 plus 5. So first step, order of operations is exponents. Then we're going to multiply these, then we're going to divide. So negative 16 times 9 is going to be negative 144. 35 times 3 is 105. And now I just add straight across. 144 plus 105 plus 5 is negative 34. So h equals negative 34 feet. And so to answer the question, is the ball still in the air after 3 seconds? This is not off the side of a cliff, right, where it can be below our starting height or below 0 and still actually be in the air. This was thrown from the ground. Okay, safe to assume that. So since it's a negative, we would answer this question, no, it's on the ground because the height is negative. So if our height is a negative number, unless we're throwing it off the side of a cliff where it could go below our starting height, still be in the air, that's the one special situation. But in general, if we get a negative height on this, that means it has hit the ground already. When it gets to 0, it has hit the ground. All right, number 3. Speed of the stone being thrown is 10, so that goes in our middle part. Notice this is meters now, and it's standing on a cliff 40 meters above the ground. So we need to go ahead and write the equation first. So h equals, this is meters, negative 4.9 t squared plus our initial velocity of 10 times t plus our height of 40. What was the height after 3 seconds? So we're just plugging 3 in here. So negative 4.9 times 3 squared plus 10 times 3 plus 40. So this will be 30 plus 40. 3 squared is 9, so it's 9 times negative 4.9. So negative 4.9 times 9 plus 30 plus 40, 25.9 meters. Flip it over. All right, special situation. We are dropping a ball, so it is not going to have an initial velocity. It is starting from 0 because it's dropped. It is not thrown and starting with a velocity. So when we write this out, we're not going to have that middle piece. We can write a 0 in there for now, though. This is meters. So part A, find an equation for the height. If it helps, still give your A, B, and C, but B is going to be 0. So H equals negative 4.9. That's because of the meters. It's either negative 4.9 or negative 16 every single time based on meters and feet, times the time squared, plus the initial velocity. He's dropping it, not throwing it. It starts at 0. The speed is 0. So 0 times t plus your starting height of 12. So if it helps you to write that in there, then do it. But let's simplify this. 0 times anything will cancel itself out. So the actual equation doesn't need that middle piece. It's just going to be the squared plus 12. So part B, when we're actually going to use this, I'm just going to go straight to this. I'm not going to worry about multiplying something by 0. So you should start to recognize this type of equation. When I don't have this middle t part, that means I don't have an initial velocity. So when something is dropped, it's going to look like this. So find the height of the ball after half a second, 0.5. So H equals negative 4.9 times 0.5 squared plus 12. So let's plug it in. Negative 4.9 times 0.5 squared plus 12. And you could round this if you want. Oh, it says round to the nearest tenth, so we need to round it. Tenth is the first spot. 7 will bump this 7 up to an 8. So 10.8 meters. Since we rounded, you technically want to put a squiggle here. All right, then let's analyze the graph where it's already done for us. Number 5, the height of the ball thrown upward is shown as a function of time on the graph on the right, so time is passing. This is what happens. So the ball is starting here and it's thrown up in the air. Eventually gravity takes over, it starts coming back down, and when it hits a height of 0, it has hit the ground. So estimate the initial height of the ball. What did it start as? So it looks to me like the initial starting height is 2. And this is in meters. Just double checking. Okay, approximately when did the ball reach its maximum height? So maximum height is right about here. If we follow that down, it's right here. So here's 1, here's 2. This would be 1.5 halfway. So it's between 1.5 and 2. 50 cents and $1. 75 cents is what's in the middle. So this is about 1.75 seconds. Now we're estimating, so if you said 1.8, 1.6, you were just guessing, that's fine. It does look to be right between these two though, so that would be 1.75. What is the maximum height? So the highest this gets is right here, 16 meters. When was the ball 8 meters high? So here's 8 meters. So it's actually going to hit that twice. It's going to be 8 meters high on the way up at about half a second, right, between 0 and 1. Half a second, 0.5 seconds. And eventually it tops out, comes back down. It will be at 8 meters high again after 3 seconds.